Okay, so we are reviewing for the final, and the first problem will be about finding inverses. So when you're given a function that has an inverse, then the way you find the inverse is using a couple of steps. So the first is you set y equal to the function. Then you switch the x's and y's. This might be familiar, we covered this. And then when you switch x and y, you get x equals negative 5y plus 3. And then the third step is you solve for y. And so if you have x equals negative 5y plus 3, the way that you solve for y, of course, is you subtract 3 on both sides. X minus 3 equals negative 5y, and then y equals x minus 3 over negative 5. And then you can put the negative in front, and so that would make it this is the answer. It's B, negative x minus 3 over 5. Number 2, when you're solving polynomial inequalities, this has a couple steps. 1, you set each one equal to 0. So you set x plus 7 equal to 0, and then x minus 3 equal to 0. And so that gives you x equals negative 7 and x equals 3. And then you draw a number line, like they have here, with negative 7 first and 3 in order. And then now you need to pick points to plug into this. So pick a value of x bigger than 3. For instance, if you pick x equals 5, take that 5 and plug it in here, right? So 5 plus 7 is 12. 5 minus 3 is 2. 12 times 2 is a plus. So it's a plus over here. If you pick a number less than negative 7, like negative 10, you get negative 10 plus 7 is negative 3. Negative 10 minus 3 is negative 13. Negative 3 times negative 13 is a positive 39. And then if you pick a number between negative 7 and 3, like 0, so I'm going to pick 0. Plugging in 0, you get 7 times negative 3, and that is a negative. So the question is, which one are you looking for, positives or negatives? And because this is less than or equal to 0, then you're looking for the negative. And so this is the answer. Now so it's all the numbers between negative 7 and 3, and so the only question now is, do we include the negative 7 and include the 3? And you do, because it's a less than or equal to symbol. So it's all the numbers between negative 7 and 3, including the negative 7 and the negative 3. That is A. Number 3, we're evaluating. So here's f of x. It's x squared plus 2. So f will take x squared and add 2. So f is going to take x minus 4. It's going to square x minus 4 and add 2. And so now all we need to do is FOIL this out and simplify. So this is x minus 4 times x minus 4 plus 2. And then x times x is x squared. X times minus 4 is minus 4x. Minus 4 times x is another minus 4x. And then minus 4 times minus 4 is a positive 16. And then we add that 2. X squared minus 8x. And then 16 plus 2 is 18. The answer is B. Here, we're writing the equation of a line, and so here's the equation of a line: y minus y1 equals m times x minus x1. And here we're given 2 points. Now they're trying to trick us with the x-intercept. One point is 3 comma negative 3, and the x-intercept is the point -3, 0. Right? So we need to do, here are our steps. 1, we need to find the point x1, y1. And then we need to find the slope. Yeah. So we can use x1 is 3 and y1 is -3. That's just this point. And now we need the slope. And the way that we find the slope is the change in the y coordinates over the change in the x coordinates. Right? And so here we're just going to use these 2 points. And so it's 0 minus -3 all over -3 minus 3. All right, so make sure we do these calculations correctly. That's 3, a minus and a minus makes it positive, over -6. And so the slope is -1/2. Plugging this in, you get, so now we're going to plug that back into this, y minus y1, and y1 was -3, equals m, which was -1/2, times x minus 3. And the only one that fits that is this one. All right, so this minus and the minus makes a plus, and the answer is D. Okay. Here, we want to solve this equation by any method. We might need the quadratic equation. We'll see. We'll see if we can factor first. So first of all, we'll bring everything on one side. 3x squared minus 11x minus 20. And it looks like we equal 0. And it looks like we might be able to factor. Now we need the factors of 3 to go here. And here's where it gets hard, because you've got to find the factors of 20 that go here and here, so that when you multiply this times this and add it to this times this, you get a minus 11 inside. And there's no set way to do it. Here it's plus 4 and minus 5 when you do the solving. And the way that you can check that is, again, 3x times x is 3x squared. 4 times -5 is -20. But then 3x times -5 is -15x. And 4 times 1 is 4x. When you add them, it's -11, which is the inside number, and that's how you know it's right. You then take the 3x plus 4 and you set that equal to 0 and solve, and you take the x minus 5, set that equal to 0 and solve. This gives you 5, so 5 is one of the numbers. And then when you solve this one, you subtract 4 on both sides. 3x equals -4. X is equal to -4 over 3. And those are your two answers. Separate with a comma. Here you're finding the vertex. So you have x plus 4 squared minus 9. The axis of symmetry is x equals -4. We can make a note here that the vertex is -4, -9. The domain is always minus infinity to infinity. The range, well, because this opens up like this, the range goes from -9 to infinity. So when you graph this, you're going to click on the click graph button, click on the parabola button, go to -4, -9, which is here, is there. And then you need to click one more point. And that point, to find the point, you're going to pick a point on the y-axis. And the way that you get that point on the y-axis is, again, you plug in 0 for x, right, into the original function. And so 0 plus 4 squared minus 9 is 4 squared minus 9. 16 minus 9 is 7. And so your second point you're going to pick is going to be 7. And then it's that. And then it will graph it for you. Here is a calculator problem. The 1983 explosion at a nuclear lab sent about 1,000 kilograms of a radioactive element into the atmosphere. This function here models or describes the amount in kilograms of radioactive element remaining in the area X years after 1983. If even 100 kilograms of the radioactive element remains in the atmosphere, the area is considered unsafe. Find f of 80. So plug in 80. And then see whether that's more or less than 100. So we need the calculator. It's going to be 1,000 times 0.5 to the 80 over 30, right? And so you got to do your calculator well. So I'm going to plug that into my calculator. 1,000 parentheses. So here's how you plug it into a calculator. So it's 1,000 parentheses 0.5 close parentheses and then caret and then parentheses 80/30. That's literally how you put it in. I'll write that again. So it's 1,000 parentheses 0.5 close parentheses caret parentheses 80/30 close parentheses. Okay, so I'm putting that in now. Get my caret done, and then parentheses 80 divided by 30. And I have 157. It says type an integer or a decimal rounded to the nearest tenth as needed. I have 157.5. Now, because that's more than 100 kilograms of something radioactive, it's still dangerous. So the question about whether the area is safe, the answer is no, because the area will have more than 100 kilograms. The answer is C. So that one is just plugging in. Here we have the function f of x equals 6x. The average rate of change is pretty straightforward. So the average rate of change is you plug in the 3 minus plug in the 0 all over 3 minus 0. When we plug in 3, so f of 3 is 6 because f is 6x, so it's 6 times 3 minus 6 times 0 over 3 minus 0. 6 times 3 is 18. 18 minus 0 over 3. 18 over 3. The answer is 6. Here when we're solving these, this is one of the last few things we did. These are pretty straightforward. If you have 9e to the x equals 19, you want to solve for x, divide both sides by 9. So e to the x is equal to 19 over 9, and then you take the log. And so the natural log of e to the x equals the natural log of 19 over 9. And then the natural log of e to the x is just x. And so x equals the natural log of 19 over 9. So here you put in ln of 19 over 9. And then for the second part, they want the decimal approximation. So when I put in the natural log of 19 divided by 9, right? And again, in the TI it goes like this, parentheses 19/9. Then that gives me 0.19 to, how many decimal places? 2 decimal places? 0.75. Here we're doing composition. So remember, we're putting one function inside the other. F little circle g means f of g of x. So that means you're going to go to 2x and you're going to replace x with g. 2 times x plus 3. So this x gets replaced by x plus 3. 2x plus 6. G of f, g takes a number and adds 3. It's going to take f and add 3. So g of f of x is equal to g of 2x. And so that means 2x plus 3, because you're just replacing this x with 2x. Now, f of g of 3, c references a. If I know that f of g of x is 2x plus 6, then f of g of 3 is 2 times 3 plus 6. That's 6 plus 6, and that is 12. So just plug 3 into this one. D, in a similar way, references part B. Plug in 3 into part B. 2 times 3 plus 3 is 6 plus 3. The answer to D is 9. Here's the addition method. So in order to solve this, we want to add these two equations. Wait, let me go back. We want to add them in such a way that they cancel. And so what I want to do is I want to cancel out the x variable. So what I'll do is, because this is a 4 and I want to cancel out the x variable, then I need to make this a -4 to cancel it. So I'm going to multiply the first equation by -4. If I did that, that makes it -4x minus 16y equals -60, multiplying the entire equation by 4. The second equation you leave alone. It's 4x plus 5y equals 5. And then, this is why they call it the addition method. Then you add the two equations. And so when you add the two equations, these cancel, and you're left with -11y equals -55. And now we can solve for y. Divide both sides by -11. Y is a very nice 5. And now that we have y, we can go back and find x. So take this 5 and go back and you plug it in there. Right? So x plus 4 times 5 equals 15. X plus 20 equals 15. X is -5. So the answer is an ordered pair, and you have to put parentheses. It's the x first, -5, 5. Okay. So that's the addition method. So multiply by the number that cancels out, multiply by the opposite of the number that cancels out this number, and you should get it. The next method is the substitution method. And here what we're going to do is we are going to substitute this y for x squared minus 16. And so it's x plus x squared minus 16 is equal to 4. So y is x squared minus 16, so you're just substituting. And so reordering, you have x squared plus x minus 16 equals 4, and then we're going to bring everything on the left hand side. We're going to subtract 4 on both sides, and then you get x squared plus x minus 20 equals 0. That we can actually factor, and so factors of -20 that are 1 apart are 4 and 5. And that's plus 5 and minus 4. So x equals 4 and x equals -5. We'll put that in 4 times -5. So I'm sorry, no. So x is, so now we need to find the order pair. So when x is 4, then we go back and find y. So let's do this one first, sorry. So when x is 4, okay, so when x is 4, you go back here and plug in 4, and when x is 4, y is 0. So one set of points is 4, 0. And when you plug in x is -5, then y is 9. X is -5, y is 9. So the answer will be these two sets of ordered pairs. So put parentheses around 4 and 0 and -5 and 9, and then separate them with a comma. So again, once you get these x values, plug each x value back into this equation to get the y value, and then write them together. Okay. Here, when we're solving this linear equation, or this rational equation, the first step you do is you multiply by x minus 2 everywhere. So we did this one in class. So x minus 2, x minus 2, and x minus 2. So first of all, the first thing you need is a restriction. So x can't be 2. And you get that by setting the denominator equal to 0. You get x equals 2. So you don't want 2. And it's just that 2 without the minus sign. If you multiply everything by x minus 2 like we did, this x minus 2 cancels with this. That cancels. That leaves a 3. 3 plus 3 times x minus 2 equals, and then this x minus 2 and this x minus 2 cancels, and that is 15. Okay? So you get 3 plus 3x minus 6 equals 15, and then you go about solving. 3x minus 3 is 15. 3x equals 18, and x is 6. Here you want to solve this inequality for x. So 0 is less than 2x, which is less than 2. I'm sorry. It's less than 2x minus 0 is less than 2x minus 2, which is less than or equal to 6. So here you solve this like a regular equation, just making sure you add 2 everywhere. So adding 2 everywhere gives you 2 is less than 2x, which is less than or equal to 8. And divide everything by this 2. You get that 1 is less than x, which is less than or equal to 4. In interval notation, that is parentheses 1, 4, bracket, because of the less than or equal to sign. 1, 4, bracket, parentheses, bracket. To find the vertical asymptotes, you just set the denominator equal to 0. Here the denominator is x times x minus 9. When you set that equal to 0, that means you set x equal to 0, and then you set x minus 9 equal to 0. X equal to 0 is already solved, and so x equal to 9 is the other vertical asymptote. And you know that these are vertical asymptotes because there's no canceling going on. So you would say at C, they're vertical asymptotes, and there are 0 and 9, and there are no holes because there was no canceling. So here we did some, we were talking about exponential functions. So 4 to the x looks like this. And so the question is, what is that, right? And so if this one is 4 to the x, what's a reflection over the y-axis? Now we have to remember about transformations. A reflection over the x-axis was a minus sign on the outside. So we would expect that a reflection over the y-axis would be a minus sign on the inside. And so that would be D. right? Because this is just this graph here is just a reflection of this graph over the y-axis. And if you're reflecting over the y-axis, that means you're putting a minus sign on the inside. We're solving for logs. So you have 9, the natural log of 6x equals 36. Solve for x, we divide both sides by 9. Natural log of 6x equals 4. And then here, we just have to remember that the base is e. And so by definition, this means that e to the 4th power is equal to 6x. E to the 4th power equals 6x. We're solving for x, so we divide both sides by 6. E to the 4th over 6. We're going to put that in. That's nice and ugly. And they ask for a decimal approximation. So again, you would do e caret 4. Maybe put that in parentheses /6. And when I put that in parentheses, or when I put that in the calculator, I get, so it's second, e to the 4th and then divided by 6. I get 9.099, and it wants me to round the 2 decimal places, so I get 9.1 even. 0.10. And finally, this one, I think this is the last one. So we know that for logs, division turns into subtraction. And so this is equal to log base 3 of 9 minus log base 3 of the square root of x plus 5. And so we're almost done. Log base 3 of 9 is the power you need to raise 3 to in order to get 9. That number is 2 because 3 to the 2nd is 9. Now we can reduce this just a little bit because this power on the x plus 5, the square root is the 1/2 power. And so we can bring that 1/2 in front. That's one of the log rules. So bringing that in front, you get 2 minus 1/2 log base 3 of x plus 5. And that is the answer they're looking for. So we're using 2 rules here. The division turns into subtraction. And here you just use the fact that 3 to the 2nd is 9, so that's a 2. And then this square root symbol becomes a 1/2, and you can bring it in front. Alright, I hope that helps, and I will talk to you soon. You can always email me if you have any questions.